Hello everyone, in this video we are going to see question 4 of exercise 8.3 which belongs to class 9 Ganita Manjari book. We'll look into the question. Which term of the GP 2, 6, 18 is 4374? So a GP is given, so it's going to be 2, 6, 18, and one of the term in this GP is going to be, that means I can write that as Tn equal to 4374. So which term it is? That means we need to find the value of a n. So first, before that, we will write what are the values of and a and r. So what is the value of a from the given GP? It's nothing but 2. And what is the value of r? It is 6 by 2, which is equal to 3. Now we'll proceed with the given value, that means Tn. The nth term is 4374. Then what is the value of en? So how can we represent the nth term using the formula a r to the power n minus 1, which is equal to 4374. And we know the value of a, which is 2, and we know the value of 3, that means r also, which is 3 to the power n minus 1, which is going to be 4374. Now we can move this 2 to the other side so that the number is going to get simplified even further. 4374 by 2. So we will be getting 2 times, this is for 1 time, 8 and 7. So over this side on the LHS, I can write this 3 to the power n minus 1 as 3 to the power n divided by 3. And in the next step, we can move this denominator 3 to the other side. 2187 into 3. So if you do the prime factorization of 2187, it is equivalent to 3 power 7. Okay, so I'm going to write, instead of 2187, I'm writing 3 power 7 into 3, which is 3 to the power 8. So what we are getting, 3 to the power n is equal to 3 to the power 8. So 3 and 3 you can cancel and we can equate n equal to 8. So this is the answer for the first part. So this 4374 belongs to which term? 8th term of the given GP. And still we need to find explicit formula as well as recursive formula. First we will find explicit formula. Explicit formula is just you can take the Tn value only, so no problem in that. So Tn equal to a r to the power n minus 1, right? So you know what is the value of a, which is 2, and what is the value of 3? That means r, it is 3 to the power n minus 1. So the explicit formula is Tn equal to 2 into 3 power n minus 1. So this is what our explicit formula. And still we need to find the recursive formula. What is recursive formula? We are going to define a particular term based on the previous term value. Can we see how to do that? So for making the recursive formula, first we will make some sequence, then it will be easy for us. See, for example, the term T1 is having a value 2. And what about the term T2? So how we are getting this 6 with the previous term, that is 2, we are going to multiply 3, right? So now we are going to find the third term. So we are going to take the second term, with that if you multiply one more 3, so we will be getting 18. So this is what the sequence. So previous term, if you multiply 3, we are getting the current term. So how can I write this with respect to recursive formula? So T1 equal to 2, right, where n is equal to 1. And if I want to find any other value of Tn, so you need to take the formula as 3 into t to the power n minus 1. So for what? N is greater than 1. So this is how we need to write the recursive formula for this GP. So can we verify? See, for example, I want to find T2. Okay, so how I'm going to take the formula? 3 into T2 minus 1, so it's going to be T1. So 3 into, what is our T1? 2, which is going to be 6. So we got the T2 value as 6. Yeah, correct, right? So this is how you can frame the formula. So we have completed finding value of n as well as explicit formula, and also we completed the recursive formula. Here ends the problem. Thank you.